In the previous video, we used table C to find the T-star values for a 90% confidence interval or a 95% confidence interval when we use a T procedure, and we also saw how we can use the same table to find the p-values for a given T statistic. So it's all about the T procedures and how the table was used to find the various values that we needed. Now, for this video, I'd like you to keep table C in front of you, and we'll discuss how to find the various values that we need from table C. So the first problem says find T star for a 90% confidence interval, and it's a T5 distribution. Usually, if it is written this way, the 5 is the degrees of freedom. Recall that the degrees of freedom is 1 less than the sample size, which means that the sample size is 1 more than the degrees of freedom. So if the degrees of freedom is 5, then the sample size would have to be 6. But what we need really for looking for values in the table is the degrees of freedom. So this is exactly how we do it. We look for degrees of freedom 5. We go across the row for degrees of freedom 5, and then we look for a 90%, which is the column headed by 90%. We go down that column. Where the two intersect, that number gives us the T star value, and that T star value is 2.015. So if you have the table in front of you, it's easy to understand exactly what I'm explaining. Now the next problem says find the T star value for a 98% confidence level. So we have a T21 distribution. So a T21 distribution would tell us that the degrees of freedom is 21, which means that the sample size is 1 greater, which is 22. Using table C again, we first look for degrees of freedom 21. So it's the row headed by 21. And we go across the row, and then we look for a 98% confidence level, go down that column, and where the two meet would be the number, it looks like the number here is wrong. Now clearly something is wrong with these numbers, but if you have the table in front of you, you've probably already identified this particular number. Now let's look at finding the p-value, let's say a two-sided p-value. For a t statistic, so t equals negative 1.23 and a sample size of 38. So in a t procedure, we absolutely need to know the sample size because unless we know the degrees of freedom, it's impossible to find the p-value using table C. So another thing that you'll notice if you have the table in front of you, which you should when you're watching this video, is that table C has only positive values of t. But because of the symmetry of the curve, this is what a t distribution looks like, and it only gives the p-values for positive numbers. So let's say we have a p-value for 2.01 and it's something, it's some number here. Then for the negative 2.01, because of symmetry, this value will be exactly the same. So if this is A, then this would also be A. So we don't need the table to show us all the negative t values because we could use the positive t values to find the p-value for any negative t star. So if we have t star equals 1.23, then what we need to do, negative 1.23, then we need to just find the p-value for positive 1.23. So the degrees of freedom is 38. Now this gives us, the degrees of freedom is 37. Now the table doesn't have any information about the degrees of freedom 37. So we look for the closest degrees of freedom, which is 40. So we look at the row headed by 40 and we look for the number 1.23 in that row. Now obviously we are not going to find 1.23. However, we find two numbers 1.050 and 1.303 between which our T star lies. Now based on these two numbers 1.050 and 1.303, we're going to find the two p-values for those two numbers, and our p-value is going to sit between the p-values of those two numbers. So if we have 1.050 here and we have 1.303 here, we go down this column and we go down this column and look for the p-values, that is the one-sided p-values for those two numbers. So for 1.050 it's 0.30 and for 1.303 it's 0.20. Notice that this is a smaller number. So the p-value that we need lies between the smaller number 0.20 and the larger number 0.30. Now in the next problem, we need to find the p-value. It's a one-sided p-value for the t statistic T star equals 0.535, where the degrees of freedom is 13. So we look at the row headed by 13, which is for the t distribution for degrees of freedom 13. And we are looking for the t value of 0.535 in that row headed by 13. Now the smallest number that you see is 0.694 in that table, and our value 0.535 is smaller than 0.694. So you're looking at the t distribution for 13, and the smallest number that you see there is 0.694, and our number is more to the left, which means it's smaller than 0.694 because it's 0.535. So how do we find the p-value of 0.535? We go down this column, find the value, p-value associated, a single-sided p-value or the one-sided p-value associated with 0.694, which happens to be 0.25. And if you notice, the values, the p-values get larger as we go to the left. Notice all the p-values at the bottom of the table C. The values get larger as we go to the left. So that tells us that our p-value is greater than 0.25 because 0.535 lies to the left of 0.694. So our p-value is greater than 0.25. Now we look at another example. We're trying to find a two-sided p-value. So we have a two-sided test, so we need a two-sided p-value for a t statistic of 10.2 when the sample size is 11. So degrees of freedom is 1 minus, or rather it is degrees of freedom is sample size minus 1, which is 1 less than 11. So if it's 1 less than 11, it's equal to 10. So the degrees of freedom is 10 and our t statistic is 10.2. So in the row headed by degrees of freedom 10, we go out looking for the t statistic of 10.2. But what we notice is that the largest t statistic available in that distribution is 4.587. And our number happens to be way to the right of this number, which is 4.587. So our number is to the right. So it's basically off the table. It's off the charts. So what we then do is go down that column and look for a two-sided p-value for 10.2, and it happens to be 0.001, which is really small. Another thing to notice is that the p-values as we go to the right get smaller. And because they get smaller, we can assume that the p-value for 10.2 is smaller. So this is smaller than the p-value for 4.587, so we know it's smaller than 0.001. So the p-value that we need, we don't know exactly what it is, but we know that it is smaller than 0.001, which tells us basically that it's a very small p-value. And if we take a significance level of 0.05, then definitely we're ready to reject the null hypothesis.